everyone. How are you all? I hope you all are great. Everyone is doing very nice in your life. And yeah, welcome to the class 9th chemistry. And yes, why I'm welcoming you because it's the very first chapter of your session that is for the class 9th chemistry that is called as the states of matter. Until now, what you have studied about in your class 8th or 7th, you are going to apply it here. Okay, and I hope you all have studied very well in your last classes so that it would be going to be very helpful in these class. Fine, students. So today what we are going to start the chapter is states of matter. Fine, so the chapter name we can write down here. It is the states of matter. States of matter. So students, today we are going to have a general discussion about the states of matter, and even though it would be a very interesting chapter and also a very gaining chapter also, that means it is a very easy and very interesting and very scoring. So you can find out that okay, that chapter is going to be fixed in your mind whenever, like, even though after 2 or 3 years, because it is a very simple chapter, you can relate it directly with your daily life examples. Like, we can take 100 of daily life example related to this chapter, that is the states of matter. Okay, but before starting with the session, I would like to introduce myself. So, my name is Arushi Sharma, and I'll be your teacher for chemistry subject. And yes, I'm going to teach you states of matter. So, that's how, student, we'll start with our session. And okay, so before starting my session, actually, what I want is I want you to make some introduction to this chapter, that what this chapter contains. So, students, like, starting with this chapter, what I want to tell you is, if I ask you that what is liquid, okay, that I just want to make you understand that what we are going to study in this chapter. So, if I ask you what is liquid, so you'll say, ma'am, liquid is water, or like we have seen water which is in the liquid form, or oil is in the liquid form. So, that's how we say that it is the liquid. Exactly, you'll say this thing. But, student, in this chapter, the definition of the liquid is going to be changed, or the definition of the solid is going to be changed. Like, till now, whatever you have seen in your life about the water, you are going to study the properties of water right now in your subject. That wouldn't be interesting? Exactly, that you are going to study those properties and see why this chapter is going to be so easy for you, because you can relate it with daily life examples. Okay, so, yes, starting with these sessions. So, the topics which we are going to cover today is that we are going to have a very general interaction with the states of matter, like what could be its characteristics or the molecular nature, and everything we are going to study. And we are having so, like, we are going to look at a very interesting videos, also interesting experiment, also, that after hearing all these experiment, you'll say that yes, ma'am, I have noticed this thing. Then you'll say, okay, this would be a very easy chapter for me to cover up. Fine. So let's start with our chapter now. So, students, if first of all, I would like to ask you that what could be the general introduction, that what could be the states of matter you can think. So, first of all, student, I would like to tell you that what is the matter. See, if I give you a very scientific language or the definition about it, so we can say that matter is something which occupies a space and have some mass. Okay, then it is called a matter. See, students, like when you have taken the birth, like from your childhood to this age, you have seen so many things around yourself. Exactly, like this pen is around me, tablet is, the laptop is there, table is there, chair is there, or there are so many things around us. So, students, like all of these things which are present in our environment or in our surrounding, we name them as matter. Why we call them as matter? Because I have told you the definition that matter is something which occupies the space and have mass. That means even though if this pen is there, this pen is also having some mass and it will occupy some space in the surrounding, and that is why we are calling it as the matter. It's not like that that I'm telling only about the solid object. It's about everything, that if we are having gases, the atmosphere, this atmosphere is also occupying the space, and even though it is also having its mass, so what we can say that yes, air is also considered as a matter. So student, from that point of view, you can imagine that you have surrounded by matter only, even though your bed, cushions, everything, that the substance in your surrounding which is having a mass, or which occupies some space, that is called as the matter. So it's not like that, student, that you will say, ma'am, that the air is having very less mass. If the mass is about 0.00001 gram also, then also it is all considered as a matter, because matter is what which occupies some space and have some mass, that is called as the matter. Fine, got my point. Now if I want to ask you that what could be the matter or what could not be, so I'm just writing the example: air, water, bed, table, childhood, happiness, spoon, pen. So my dear students, like I have written some of the list here, so what you can say that among these list, what can be the matter or what cannot be the matter. So students, what I have told you about the matter is that the introduction which I have given you, that the matter is something which occupies the space and have some mass. That means in your surrounding, the things which you observe, that which is occupying the space and having some mass, that is considered as the matter, which you can see from your eyes. Exactly. So even though you'll say that, ma'am, air we can't see with our eyes, but you can feel it now, that the air is there and the air is also having some mass in it. So that is why, student, air would be considered as a state of that is the matter also. Water is a liquid is always having their mass and they always occupy the space, so that is why water is also a matter. Bed, you know that we used to sleep. Exactly, we use bed to sleep, to sit, and to take relax everything. So the bed is also something that in your room you have a bed, so that bed is occupying the space of that room, and even though it will having a heavy mass. So student, is like that, that the matter would be kind of the thing that one can be having a very less mass, or the one thing can have a very heavy mass. Exactly, so it's not like that. We don't have to consider the factor of heavy or light. We just have to consider that whether it is having some mass or not. Even though cotton, you say that the cotton is a matter? Exactly, because it occupies space, and whether if it is a very lightweight, but it will have some weight. Same nature with the air, that air will having very lightweight, but it will occupy all of these spaces. Exactly, that all of the surrounding we are having air. Like if you're sitting in your room, you are inhaling oxygen, so oxygen is a part of air only. That means you are inhaling oxygen. If you go somewhere else, so you will find same oxygen there, you will inhale oxygen there also. So that's how air is every around us, so that is why air is also occupying the space. So we considered it as a state of matter. Bed would be the state of matter, table would be the state of matter. Now the situation comes here when you have to decide that whether the childhood can be considered as a state of matter. Childhood is what? Childhood is the feeling, or you can say that which we can feel only. It's not like that if that it is occupying some space. Have you seen that childhood or the happiness is occupying some space, or it is having mass? That okay, childhood is 5 kg, or his childhood is 10 kg, or his childhood is 12 kg. It's like that. No, even though that the childhood is not considered as a matter, because it is a kind of feeling which we can feel only. Even though happiness is also that, by looking my face you can tell me that how much mass or the how much kilogram of happiness I am feeling. I am having, okay, today I am feeling 5 kilogram of happiness, now tomorrow I am feeling 10 kilogram of happiness, yesterday I was feeling 5 kilogram of happiness. It's not like that. Exactly, so now you can come the difference, you can see the difference between the that how we consider something as a matter. So student, yes, everything around is a matter, but it should contain some mass and it should occupy some space. That's the point. Okay, so that is why childhood and the happiness could not be the matter. Now spoon is what? Chammach. Exactly, we use spoon to eat food, we that is occupy space also, and it also have mass. So spoon and pen, even though pen is a very lightweight, but obviously if we are keeping it on the table, so it is occupying its space, and even though it is having some mass, so that is the matter. So you can say that everything around us is a matter, but it's just that the thing which we are considering as the as that they are not the state of, that they are not including in the list of matter, is just that they are not having any mass. Fine. I hope you all understand that what exactly the matter is. So like everything in this universe, it made up of material which scientists have named them matter. So student, this name has been given by scientists. Fine. So there would be no any reason that why we are calling it as matter. It's just that scientists have given it this name, but the definition and the importance matters. Fine, students. I hope you got the introduction about the matter. Fine. So students, what I can do that I want to show you one interesting video related to it. Do you want to see that video? It would be a nice video. You will get amazed about it. Okay. So we'll see that video. Just a second, my students. I would like to show you that video. I hope my students are not getting bored of my lecture, because I'm trying so that you will get each and everything, my students. Okay, so here's your video, and I hope you all are excited to look at this. Just a second. Okay, so are you ready? Okay, I'm also ready. So please be excited. Please be very thoughtful that, okay, what is the chapter? And now starting with the video.
Matter. Since early times, human beings have been trying to understand their surroundings. As we look at our surroundings, we see a large variety of things with different shapes, sizes, and textures. Everything in this universe that we see is made up of material, which is called matter. Matter occupies space and has mass. All matter is made up of tiny particles.
So, student, do you heard that what she's saying, that even though we are looking at our the surrounding, we find so many things and they all are different from each other. Whether they are having different functions, but even though they are having different size, different shapes, different texture. So all of these things that which is made up of material, or like she have mentioned one of the very important thing, and that important thing from the point of view of your syllabus is the tiny particles, that every matter is made up of the tiny particles. Okay, and how they are made up of it, we'll see that how we can conclude it. Okay, so now again going back to the video.
If we were to observe sunlight falling through a window, we would be able to see tiny particles floating in the air.
So students, like she's telling that whenever there is a window and if the sunlight is coming through it, and so we see some particles floating into the air. So have you also noticed that? Because I have noticed that generally in the case of the winter season, when there is a very bright sunlight and it is coming to some source, so what will happen that I have noticed that thing, that very small particles were floating in the air. So that's how these are these tiny particles which made up the environment. So you can also say that even the if there is the solid, if there is something else, so they all are made up of tiny particles. Fine.
These particles have spaces between them. Let's demonstrate that using the example of salt dissolved in water.
So yeah, we'll see that how it would work, that okay, how we consider that okay, all of the matter, whether it is the liquid or whether it would be solid, so how they are having tiny particles present in it. So we are having some experiment for it, and we'll see that how we do the experiment for it. So some of the common examples of the matter that we can see, that it could be any example. If I ask you that what can be the example of matter, so I think you will start, and the list would not going to be end up, because we are having so many examples related to state that is the matter. Okay, because everything around us is the matter. This pen, my book, my table, my chair, my laptop, everything is a matter. Exactly, students. So that's how. Now, how we can say that the matter is made up of the particles? So yes, student, matter is made up of particle, and these particles are having space between them. And how? So we are going to look at this video in which you can observe one of the experiment. Fine.
When we dissolve salt in water, the particles of salt get into the space between the particles of water. Also, you will observe that there is no change in the water level. Thus, we have found that particles have space between them. You will also see that the particles continuously move. A drop of ink slowly spreads it.
So students, like how we observed or how we see that okay, that the matter is made up of tiny particles, but how we conclude that thing that okay, they are made up of tiny particles? See student, like the experiment she has done, like for the salt water. Okay, we'll see that. But first of all, if I tell you that okay, that sunlight example which we have taken, that the sunlight is entering into the room, and we have seen that okay, there are the particles floating into it. Exactly. But now if we consider the experiment for it, that if we take the example of the salt solution, fine students, like okay, what I can do is that I can ask you to do this experiment at your home, that in there is the one glass is there. Okay, and in this you are taking this much of water. Fine. Now when you have add the 1 spoon of salt. After adding the salt also, what you have observed, that the glass is having the same amount. Okay, so that means the water is not going to be changed in it level. So what's the reason behind it? Like okay, you are taking for example, you are taking 20 ml of water, or like 50 ml of water in a glass. Okay, you have taken the 50 ml of water, 50 ml of water. But now you have to add 1 spoon, 2 spoons. Okay, I'm saying that you have you have added 3 spoons of salt. Fine. Now, after adding the 3 spoon of salt, have you ever noticed that the level of the water which is present into the glass has been raised up, or the amount of the water is going to be changed? That initially it was 50 ml, but after the addition of the 3 spoon of the salt, it is going to be 55 ml. Have you ever seen that? That you can do this experiment in your house also at your home. That one glass you have taken and you have filled that glass and you have added 1 spoon of salt. So have you noticed that the water is going to be increased by level? Exactly, no. So that's the thing, that okay, this thing make us understand that okay, the matter which we are having, they are having particles, and these particles are having spaces between them. And because that particles we have observed in the sunlight, and even though all of these things are having the particles, but the statement which comes that particles are having interspaces between them, it is because we have done one of the experiment. Exactly. Like if I see the example here, that okay, we have taken 1 glass of water, and initially it is just the itna, and after adding of the 3 spoon of salt, it is like it is equal. It is not going to be increased or it is not going to be decreased. Exactly, but it is just the same. So what's the reason behind that? Even after that adding some water in it, that adding some salt in it, why we are not going to be increased that level of water? Exactly. But students, like if what we see that okay, if some heavy material we are putting into the water, so exactly the level of the water is going to be increased. Okay, it is because of the difference of the nature, whereas the salt is soluble in water. But if we talk about stone, so if I put the stone into the water, that stone is not going to be dissolved. Fine. So that's the property of the salt. Now why we can see that why it is happening right now. So see students, okay, this is the glass. I'm just drawing somewhat large size glass so that you can understand it easily. Okay, and we are talking about water. So these are the particles of water. Okay, this is the level of the water, I can say, and these are the particles of water. Now, students, you can see that these particles are having spaces between it. When you have added salt into it, okay, salt. So what will happen? That salt, the particles of the salt will occupy the space between it. Okay, and that's how it is going to be dissolved into the water when you stir that glass. So it is going to be dissolved into that water, and that's how, student, the level is not going to be rise up. And even though after mixing it, you will feel that okay, now water has become salty in nature. Exactly, if you taste that water, it will feel some salty, because the characteristic of the salt particle has been dissolved into the characteristic of the particle which is of the water only. So that's how, student, we come to know that okay, matter is made up of the tiny particles, and that tiny particles are having spaces between them. So this is one of the experiment. We are having number of experiment about it, that we are having so many evidences about it, which we are going to discuss right now. Fine, students. So now coming to the point, that okay, particle of that, okay, that it is present in the form of the particle only. Exactly. Now, student, there would be the evidences that how we can see that the matter which we are looking at, okay, we find it out, okay, that they are made up of tiny particles. But how we can say that these particles are having spaces between them, or how they are present in the particle nature? So, students, we I'm just going to show you one of the experiment here again. Please look at that video very seriously, so that the thought of the matter, that because what the thing is, now whenever your mother is going to prepare salt water or sugar water, that means sugar solution in front of you, so you'll tell your mother that okay, mama, that this water is having space between this. And you can ask one question also, like to your sister, to your brother, that okay, I'm taking this much of water in it, now I have added the salt in it, now I'm adding second spoon of it. Why the level is not going to be rise up? So she or he will get confused, and that's how you can explain that the water particles are having spaces, and that is why when salt is added into it, so the particle of the salt is going to fill up that space, and that's how we are getting salty water. Okay, I hope that it would be an interesting thing for you, and you can do some experiments from your own also. Okay, so students, like we can see, that we can see the another video, because it would having the more interesting examples. So we'll see that. Fine, just give me a minute, I'll just show you that video. And I hope, my students, you are getting each and everything. Okay, so here is our video. So we'll see that and we'll enjoy it. And even though what I want is that I want to make you understood each and everything very clearly. Okay.
Hello and welcome to another Science Vision video. Now in this video we're going to look at evidence for particles. Now we know that particles actually are very, very small, and we're told about this all the time, but what evidence is there that these particles actually exist? Well, there's actually two simple experiments we can carry out to prove that they do exist. The first one is called dilution of coloured solutions. The second one is looking at different diffusion experiments. Let's start with dilution of coloured solutions. Now suppose
Okay, so students, the experiment which he want to show you, that it is the dilution of the solution. Dilution means, student, that we are going to add up the water one by one into the beakers, and you will observe that how it is going on. Okay, so that you come to know that okay, finally, that the particles are having spaces between them.
you have a beaker, it's a beaker of water, and you put in the middle of that beaker of water a blue copper sulfate crystal. Now just think for a second, what's going to happen to that blue copper sulfate crystal? Will it stay there or what? Well, actually what happens is you'll find that the particles eventually will spread out throughout the whole container. So the whole container becomes blue. Now if we dilute that, what happens? If we dilute
Okay, so student, now what we have done, that we have taken one of the beaker, and that beaker contains the water, as you can see in the picture also. And in that picture, you can see that we have put one of the crystal of copper sulfate. Okay, so the copper sulfate crystal is having a blue color. Now, after some time, what you have observed, that the blue color of that copper sulfate salt has been dissolved into the water, due to which the color of the water has been changed. That is the blue in color. So student, now you can imagine that how the color is transferring from the blue color copper sulfate crystal to the water, it is just because of the particles which are present in the water, they are having spaces, so that the particles of the copper sulfate is dissolving into it that spaces, and the color of the solution is changing. That's the reason behind it. Okay, now after some time, what will happen, that you have dilute that solution. That means if this much is water is there, you have added some water in it. Okay, there is the water. Now what you will find, that after some time, okay, that the water which we have added into this beaker, it is going to be show some color, but it is having some light color, because student, what happened, that the particles which are present initially, they are now going to be divided along, so that all of the solution will contain similar color, and that's how there would be the some color change. Okay, observe it carefully.
Dilute it again, the particles spread out to occupy the whole volume of liquid there, and again and again. So what we can say here is a serial dilution of a solution such as copper sulfate provides evidence that the original crystal was made up of many small particles, and these spread out evenly when the solution is diluted by adding.
So student, have you seen that when we have diluted the solution, that means when we are adding water one by one, like initially I have taken 50 ml, then I have taken 40, sorry, initially it is 50, then I am increasing the water content, then it would be 60 and 70. So what you'll see, that you will see the difference of the color, that one would be the darker one, then another one will be the light, and the third one will be the lightest one. So the reason behind is that when the particle of the water is increasing, so what will happen, due to which the particle of the copper sulfate has to be dissolved more and more, due to which the color of the solution is going to be decreased. This experiment you can also do your home, like from which what you can take, like you can take your color, that is the watercolor. We use watercolor for the drawing now, so you can take that watercolor. Okay, what you can do, that in your one beaker or in your one glass, you can take the full that half glass of water, and you can put one drop into it. Fine. And see student, I'll just show you that how you can do it. This is the first beaker. Fine. And in this beaker you are taking this much of water. Okay, this is the water here, and you are adding one drop of, for example, red color you are adding. Red color. Fine. And that red color, that is the watercolor which we use generally for our drawing purpose na? So that is the watercolor we are taking. So we have put one drop into it, you have stirred it, so what you find out, that the color of the water is going to be red. Fine. Now further what you will do, that okay, this is the beaker, the same beaker is there, but now you have add some water into it. Now the water content increased to this. Now what you will see, that after this, that this red color would be light, it would be light as compared to the previous one. Now again what you can do here is, that when you have taken the beaker, and if you have increased the water content to it, so what will happen, that now the color would be the lightest, that red color would be at its lightest. So that's how student you can see, as the water content increases, so what we can see, that the particles of the water is going to be increased. You can see na, that the water is increasing, so the particle of the water is also going to be increased. So the red ink which is present into the water, it has to be distributed among all of this water, and due to which the color is going to be different, and it should be going to be light also. So that's how student we can see that the particles are mixing with each other, and that's how we have seen that okay, particles are having spaces between them. Fine.
Water. So that's our first bit of evidence here that all stuff is made up of particles. What about the second piece of evidence? Well, the second piece of evidence is diffusion. Imagine this is your living room.
Okay, so the first one we have discussed with the help of the dilution of the water. Now the second we are going to discuss on the basis of the diffusion. Now you'll say, ma'am, what's the diffusion? So student, diffusion, you can say that one thing when diffused with another thing, that mixed with another thing, so that they overall give some one type of the characteristic, then it will say that it is the diffusion. So the experiment which he is going to show you, you can also do it at your home.
As you spray in the corner of that living room some air freshener, does the air freshener just stay there? Is this only part of it smells fresh? No. What actually happens is the particles will spread out in all directions. So eventually you find the whole room has got that air fresh smell, whether you like it or not. Let's look at some other examples now of diffusion. This is nice, wasn't it?
So students, like what he have said to you that okay, in your room at any one corner you have sprayed the room freshener, but after one time what you'll see that okay, that freshness is going to be each and every point of the room. So what's the point behind it? So you can take this example on your own. For example, student, that you are sitting in the room in your house and you are feeling some that okay, that the smell is not good, that the smell is not pleasant. So what do you do? That okay, you'll do room freshener. Exactly. So that room freshener, when you spray into your room, so that freshness of that room freshener which we are using, it is going to be surrounded in overall that room. Exactly. It's not like that at one corner we are having freshener but another corner we are not having it. It's just that the particle of the freshener is going to be dissolved into the particle of the air, so that we are having freshness overall. For example, student, we can take another example also, like your room is here and your mother is cooking some food inside the kitchen. Exactly. But she's cooking like some yummy cake. Okay. And that cake, if you see that the smell of that cake is coming to your room also. So what's the reason behind it? That she's cooking that cake or she's making that cake in the kitchen, but you are getting the smell of it, because sometimes you can observe now that your mother is preparing some surprise, but by mistake that smell got released, and due to that you will say that okay mama, what are you cooking? Exactly. So that's the point, student. You are still sitting in your room and you are getting the smell from the kitchen. So that's the reason that the gases which is releasing from that cake, not exactly gas it, we can say that the smell of the cake is going to be dissolved into the air, and by passing on the air you are getting the smell from it. Even the student, like if you have seen the Tom and Jerry cartoon, so in that case you have seen that Tom and Jerry, like or any other cartoon, so there would be some smell kind of thing. You'll see that okay, if there is anything is going to be prepared or for the eating purpose, so what you have seen, that cartoon will get the smell of it by smelling that from somewhere else. So that's how we also get that smell. Fine. So that's the reason, because the particle of that smell, that particular freshener or particular food is going to be dissolved into the air, and that's why traveling through that air, because the air is also having particles which is having space into it, and the particles of the food smell is going to be dissolved into it, and that's how we are getting the smell of it. Fine. I hope you can relate these example with your daily life. For example, now I am having third example also. Like one day you went to school, okay, and like on that day you put some deodorant over you or perfume over you. Fine. And when you have entered in your class, so exactly your teacher, your student or your classmate didn't know that today you have applied the perfume. But at the point when you entered in your class, at that same point or after 2 or 3 seconds, your teacher and students will start recognizing, oh, that someone has used up the perfume or deodorant, or someone has come in the class by taking perfume or the deodorant. So what's the reason behind it? Because the smell of the deodorant or the perfume is going to be dissolved into the air of that particular room, due to which they can also smell it. So that's all the reason, that the particles are there and they are having spaces between them, so that the other particles can dissolve into it and we get smell, or we can see some evidences here. So that's how, student, you can get many evidences in your daily life, and you can also observe that yes, due to the spaces between the particles we got some characteristics. Fine, students, I hope you got this point, that okay, matter is something which have space and occupies mass, and then they are made up of the tiny particles, and that tiny particles contains what they contain, spaces between them. I hope you got this point. So can we move ahead? So like I have given you so many examples, so you can also think from your like you can also think it that okay, what could be the another example for it? Okay, what could be the evidence? So I am just giving you 1 minute. Can you also recall that what could be the example? So students, like I have discussed, so there are so many examples. Sugar solution is there. Even those students, like when we prepare coffee or when we prepare tea, something like that. So what we are doing, we are adding things into it now. So what will happen that the water which we are using for preparing tea or the milk which we are using preparing the coffee, so we are adding coffee into it. So it is going to be dissolved into it. So that's why the milk is having particles which are space, which are having space. So the space of that milk is going to be filled up by the particles of coffee, so that we are getting the taste of coffee. Exactly. If the coffee is separately and the separate and the milk is separate, that so how you are going to prepare coffee? That okay, what we can do, first of all we drink milk and then we take one spoon of coffee and then we can jump, and that's how coffee can make inside our stomach. You can do that. That's how you can drink coffee. Exactly, no. So what we do, we use one pan, we put like we take some amount of milk, then we add some amount of coffee. So that's how we prepare coffee. Exactly. So because the particles are having spaces and we are getting the taste of coffee due to the due to the solubility of that, that you can say that the coffee into the milk. Fine, students. Okay, now coming to the characteristics of particles of matter, that what could be the characteristics of particle. So first of all, students, like they are very small in nature, that by looking at any particular thing you can't tell that what is the particle here. Exactly. Like if you can see this pen, so can you tell me you can see the particles in it? Exactly, no, you can't see with your naked eyes, because you can see, because they are very very small in nature, so you can't see them. That, but you can say that yes, the particles of the matter are having space between them. Why we are saying that? Because students, we have done so many of experiments, we have taken so many examples from which we can conclude that yes, exactly, the particles of the matter are having spaces between them. It's just, student, that whenever, like when we are going to discuss about the three states of matter, we'll see that okay, there would be the difference between these spaces, but all of them are having space. Some, that one will have more space, one will have less space, but every state of matter are having spaces between it. Okay. For example, if I talk about this pen is also having particles, but that particles is also having space. Whether it could be very tiny space, but it will definitely having some space, so that we are getting mixture or something like that. So all are these the evidences. Fine. Moving towards, particles of matter attract each other. Now why I'm saying this thing, that what, why it could be the characteristic of particle, because students, the solid things which we are having, you have seen that they are so much solid in nature or strong in nature. For example, in this example, you can see that the picture which is given to you, that this is the iron ball, and if you're hitting with the hammer, so it is not going to be destroyed easily. But if we have taken the chalk, so what will happen, that if you put the hammer over it or you hit it with the hammer, so it is going to be break down into pieces. So student, is just that okay, every particle in the matter, yes, attract each other. That is how they are giving some shape to any particular thing. Exactly. If there is no attraction, so there will be no definite shape. If there is the attraction, then only we are getting the definite shape of. So like in the iron ball, the attraction is very much, due to which it is not going to be breakdown. But if we talk about chalk, the chalk particles are not having that much attraction, due to which on hammering it, we are getting it into the powder form. But yes, particles of matter attract each other. That's how we are getting the definite shape. Fine. So that's the point. Now the next thing is characteristics of particles of matter, that the particles of matter are continuously moving. Exactly, student, if they are not moving, so how it could be the possible? If the particles are remaining at their position, if they are not moving, so how it could be possible? For example, in this video, what we have seen, that the particles are always moving. At this point, you can see, I'll show you.
Particles of salt get into the space between the particles of water. Also, you will observe that there is no change in the water level. Thus, we have found that particles have space between them. You will also see that the particles continuously move.
That particles continuously, like they always like they always are in motion. So that's the also characteristic, that they are always moving. That's how we are getting the characteristic of matter. For example, the example which we have taken of the deodorants and everything, so how the particles, like how we are getting the smell of it, it is just because that the particles of that particular deodorant is moving. If they are moving through the air, then we are getting the smell. Now if they are not moving, so how we can get the smell? Exactly. So that's how the particles are always moving. So students, if we revise the characteristics of particles of matter, so it's just that, students, that they always, they are very tiny particles, they are very tiny, tiny of nature. And second one, that they are always moving. The particles of matter attract each other. And what else, student, that what we have seen, that the particles of the matters have space between them. And we have seen the evidence of each and everything. And even though, like by like after listening me, even though you are having any doubt, so I have already given you so many things that you can do at your home, and you can observe these things. Exactly. And that's how you can clear your thoughts, that okay, yes, this is the truth, this is the fact, that yes, the particles of the matters have space between them. And if they are having spaces, that's how we are getting the smell of the food or something like that. Exactly. And they are continuously moving. So that's the reason, and that's how they're using some experiment, like making salt solution by adding ink drop, like I have told you. You can apply all of these experiment at your home. Fine, students, you are getting my point. Good. So now it is like that, what's the molecular nature of matter? See students, we have seen that particle nature is there. Now what's the molecule nature of water? So student, is just that the water or any gas or any salt, they all are present in the form of molecules. We'll see what are the molecules. But first of all, I would like to show you this video, because it is a very interesting video. Again, so we'll see that. Fine. I hope my students are not getting bored, or if you are getting bored, so what we'll do, I'll just show you that video. Wait. Okay. So are you ready, my students, for looking this video, for understanding the molecular nature of matter?
Molecular nature of matter. All molecules of a gas are identical but differ from those of other gases. The molecules of a gas behave as perfect elastic spheres and are of very small size as compared to the separation between the molecules. All the molecules are always in random motion and they have velocities in all directions ranging from 0 to infinity. Molecules during their motion collide with each other and also collide with walls of the container. All these collisions are perfectly elastic. Molecules do not exert any force on each other except during collision. Molecules always move along a straight line between two collisions, and the distance traveled between two successive collisions is called mean free path.
Okay, okay. So student, it's like that. You don't have to confused about the mean free path or something like that. It's just that we are discussing about the molecular nature of matter. Like in this video, you have seen that the particles of the gases are constantly moving. Exactly, they all are constantly moving. It's just that the molecule of one particular gas is similar to each other. But if we talk about the difference of the gases, for example, if I'm taking nitrogen gas and the oxygen gas in one container, so the particles of the nitrogen will be similar to each other, like nitrogen, and it is okay, what I can do is, I can do use some different colors so that we can easily confuse. So nitrogen would be pink and the oxygen would be this. So the night oh I made the mistake. So it is like nitrogen, 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 nitrogen. But if we see oxygen, so it would be oxygen, oxygen, oxygen. Now these are the particles. But when I have kept it into a beaker, this is a beaker in which I'm transferring this gas. So what I've observed that the okay, this is the oxygen gas particle, but the nitrogen gas is also present in it. So that's how they are mixing with each other. So yes, they can mix with each other, these molecules, but we can see that the nature of the one particular type of the gas will be similar, but the two different gases are having two different molecules. So that's the molecular nature of matter, that okay, if the matter is present in the form of the molecules, so it is also having the similar thing as we have observed about the particles, students. Okay, so this is the thing which we have to cover up. So students, like this is the chapter, this is the topics which we have to cover in today's class. So what we have seen, students, that okay, states of matter is the chapter, and now we have discussed only and only the matter and some of its characteristics. The states of matter, what it is, we are going to discuss in the next class. It's just that it is having three types: solid, liquid, and gases, and how they are differ from each other, we'll see that, because it is a very interesting thing to see that the difference between these three. It will be very interesting, but I hope you get this point, that the matter is something which occupies space and have some mass, then it would called as the matter. And the matters are always made up of tiny particles, and we have seen many of the examples, many of the experiment, and you can also do it on your own. And if you find that okay, this experiment is successful, so you will get your point, that yes, exactly, the particles of the matters are having space, they all are always moving, and yes, they exist, that they are having attraction between them also, like the example which we have taken. So that's the point, student, that these are the characteristics and this is the matter. And in the next class we'll discuss about the states of matter, that it's solid, liquid, and gases, because all of these are the states of matter, all of these have these properties, but it's just that they are having some difference. Like in one case we'll get the force of attraction will be very much, in the another case what we find out that the force of attraction will be very less. So that's how we are going to discuss these three states of matter depending upon the properties. Fine, students. So this is the topic which I want to cover in today's class. Now the question is, what are the condition for something to be called as a matter? Like I have told you this thing now many times, that what could be the matter, that if I want to consider this pen or anything as a matter, so what is the condition? Think about it. I hope my students got the right answer. So exactly, student, it is that the matter is something which occupies the space and it should have some mass. So the condition to be called something as a matter, it would be that it should occupy some space and should have some mass. Then it would called as a matter. Fine. For something to be called as matter is that it should occupy some space and have some mass. Okay. Name two processes which provide the best evidence for the motion of particles in matter. So that what could be the processes names we can see that gives the evidence that the particles of the matters are always in motion. So students, I have one process I have told you right now. One is the diffusion. That means through the diffusion, that means particles are diffusing with each other, and that's how we are getting the smell of deodorants or something like that from one place to the another place, or from one area to the another area. Like we have taken the room freshener example, we have taken the example of cake, we have taken the example that when you went to school, you entered in your class by applying that perfume or deodorant, so you'll feel that all of the people which were present there, they all feel some smell, even though if any other person has been applied that perfume or deodorant, and if that person passes by you, so what you observe, that you are also getting that smell. That is the diffusion, and that is the evidence that yes, particles of the matters is always moving. And the second is the Brownian motion, which is we are going like this, we are going to discuss later on in this chapter only, students. Okay, so you don't have to be worried about it, that what is the Brownian motion. It's just that you will keep this thing in your mind, and we'll discuss in our chapter wise, like we'll go topic wise, so that all of these thing is going to be like clear in your mind. Fine, students, and I hope you get each and everything in today's session. And even those students, if you feel that if any query or any question comes into your mind regarding any of this topic, so you can put up your question over the forum, on public forum as well as the private forum, and you'll get your answer, and all of your doubt is going to be cleared out. And I hope you are getting everything, my students. Thank you. And yes, students, keep learning from us, IITians. Thank you very much.